Hi there, if you remember, during the previous video, a function was defined and used to have a more efficient program. In this video, another project will be implemented inside Factory IO, to learn how function blocks can be defined and used, and also what is the main difference between functions and function blocks. Before we get started with today's video, I just wanted to inform you about all the great content we have been releasing on the plcgoods YouTube channel, which includes industrial automation PLC programming, HMI, and microcontroller-based developments. My name is Syed Reza, and if you enjoy this video, I would appreciate it if you could click the subscribe button as well as the notification bell, to receive the latest and the greatest content I will be posting through the channel. Okay, let's start the video with the final project. As you see, here are two tanks. Respectively, the program can be divided into two parts that are similar together and work independently. First, let's test the left tank. Well, if the green push button is pressed, the filling valve will be open for a specific time. As you can see, this digital display determines when the filling process will be stopped. Similarly, if the red push button is pressed, my program will open the discharging valve. As you see, during the discharging process, the green push button is not working. Now, let's test the right tank. It works similarly, and as you can see, the programs of the two tanks are quite similar together, except their filling and discharging time. In this project, we're going to learn how function blocks can be used to program similar processes with different parameters. Alright, as the first step, let's design the two-tank system inside Factory IO. Well, let me start the designing step with the third predefined system. Note that digital mode has been selected for the tank. So, it only has two digital valves for filling and discharging. Now, let me duplicate the water tank system. Well, my system has been designed. Now, let me select appropriate names for the equipment. I'm going to use the selected names for the right tank as the first system, for the new inserted tank as the second system. Suitable names will help me during the connection process between the equipment and my program. Remember, the green push buttons which will be used for filling are normally open, and the red push buttons which will be used for discharging are normally close. Now, let's select the drive option under the file menu. Like the previous videos, here, I will connect the equipment to my program via an OPC server. Note that, at the bottom, you can see the selected color for each data type. Now, let's launch CODESYS and start the programming step. Alright, there are two tanks with the same performances. The whole of my program can be written here, inside the main POU. Instead of this simple way, let's see how function blocks can be used to make a more efficient program. During the previous video, the last item, function, was explained and used to implement a mathematical expression. In this project, I need a function block. It works like functions, and during the programming step, I'll show you the main difference between function blocks and functions. Well, function blocks usually have some inputs, outputs, and also some local variables. The main difference between functions and function blocks is that, functions don't store any variable for the next execution, but function blocks use a part of the PLC memory to store their local variables. Let's continue. Well, I want to use the green push buttons to open filling valves. My function block receives the state of push buttons as its input, and then determine the state of filling valves as its output. Now, let's use a pulse timer to determine how long the filling valve must be opened. Okay, this variable as an input receives value in the time format, which determines how long the filling valves must be open after pressing the green push buttons. Otherwise, my program will use this initial value, which is equal to 10 seconds. Now, let's define a variable as an output to store the timer time. Well, I've forgotten to define this variable as an output. So, let me change its scope manually. Well, the pulse timer only needs one pulse to start its work. So, let's change the type of this contact to detect rising edges, receiving from the green push buttons. Now, let's write a similar program to open the discharging valve for a specific time. Remember that, the red push buttons, which were used for discharging, are normally close. Now, let's add another condition. Suppose the two tanks are not able to fill and discharge at the same time. To implement this condition, I can use the normally close contact of each valve inside the other network in the front of the two push buttons. In consequence, now, if the discharging valve is open, this contact will be open. Therefore, the green push button won't be able to activate its timer and also the filling valve. Similarly, if the filling valve is open, the red push button won't be able to start the discharging process. Alright, This is my program to control the filling and discharging valves of each tank, inside this function block, whose name is FB_tank. The function block has some inputs and also outputs, like a function which was explained during the previous video. Note that, my program needs an important condition to work correctly. It needs to remember the state of two valves, and also the state of these timers, to determine the state of each valve. Now, let me use my function block, inside the main POU. I want to use it to control the first tank, and as you see, it needs a variable to work correctly. This variable, whose data type is FB_tank, will be used to store the local variables of the function block. Now, let me delete this contact, because I want to execute the function block during each scan cycle. Then, the first input must be connected to the first green push button. Now, let's define a time for the filling process. The next input must connect to the red push button. Finally, I can determine a specific time for the discharging process. But let's use the default time, which is equal to 10 seconds. Now, let's connect these two outputs to these valves of the first tank, and store these outputs whose data types are time, in two suitable variables. Alright, let me tell you an important point. Although, I've selected similar variables at the inputs and outputs, but they are not equal to the defined variables inside my function block. The exact name of the used variables inside the function block start with this variable. For example, pay attention to the full name of the first output of my function block. Alright, this function block will control the filling and discharging processes related to the first tank. Now, I need a program to calculate the remaining time of the filling or discharging process, and then display it on this digital display. Let me use a function to write this program. Well, the data type of the function output must be integer, because this data type has been selected for the two digital displays. So, inside the function, I will need to convert the calculated time to an integer number. Alright, first let me use a subtraction instruction to calculate this value. Now, I need to convert the calculated time to an integer number, using a conversion instruction. Well, because the conversion instruction gives me the time in milliseconds, I need to divide it by 1000, to represent the calculated time in second. Alright, let's compile the program to ensure there isn't any error, and then use the function inside the main POU. Alright, let's use the defined function for displaying the filling process time when the fill valve is open. Based on the first network, the maximum time is 15 seconds, and this variable represents the current time. On the other side, I'll connect the function output to this digital display. Similarly, let's use the function again, to display the discharging process time. Remember, the default time for discharging process is 10 seconds. Alright, this network display the remaining time of the discharging process on the first digital display. Note that, based on the program which has been written inside the function block, both valves won't be open simultaneously. So, the first digital display will display only the filling process time, or only the discharging process time. Now, let me test the whole of my program manually. Well, let me enable this variable. Later, I'll connect it to the green push button. Okay, there is a problem in my program. Because both timers and also valves have been enabled. Let me open the function block to find its problem. Alright, one variable has been used for these two timers. I must change one of them. Alright, let me test my program again. First, let me enable this input, to start the filling process. As you see, the filling valve has been opened, and the second network is calculating the remaining time for us. Similarly, this input can start the discharging process. Well, it seems my program is working correctly to control a tank. Now, I'm going to extend my program to 2 tanks. I only need to duplicate these 3 networks, and use suitable variables for their inputs and outputs. Note that, to avoid appearing the previous problem, I must select a different variable for the second function block. Alright, the programming step has been finished. In this project, I've defined a function block, FB_tank, and used that twice. Note that, each function block has a special variable to store its special parameters such as timer's time. On the other side, functions, such as FC_timer, can be defined and used for programs, which don't need to store any parameter. Well, all necessary steps related to my project have been told, except making a connection between my program and Factory IO. Because it was explained during the previous videos, let me just review it and speed up the video. If you don't have any problem with the connection process, you can stop the video, and try to do or improve my project by yourself. To make the connection, first I must determine which variables must be shared with Factory IO via an OPC server. Then, I need to run my virtual controller, CODESYS Control Win v3, and after that, download the program on the virtual controller. Well, CODESYS cannot detect any controller, because I've forgotten to disable the simulation mode. As you see, now, it can find and connect to my controller. Now, I need to use kepserverx software to create my OPC server. Before, I've defined this channel with these tags, which are connected to the selected variables in my program. As you see, the connection quality is good. Now, I must open Factory IO to connect the equipment to these tags. Alright, as you can see, function blocks can be used to implement one program for similar systems with different parameters. In this project, the two tanks use different time to open their filling and discharging valves. Thanks for watching my content. If you have any question on this topic, make sure you leave them in the comment section below, and if you can spend a few seconds of your time liking as well as sharing this video, if you enjoyed it, that will mean a lot to me. If you have any suggestions for the channel, such as what kind of hardware or software I should be covering, then make sure to leave that in the comment section. See you next time. Bye bye.